In this video, I want to introduce something called the noise bandwidth to you. Okay, so let's imagine this scenario where you have noise, which is a white noise, which is basically white noise. Okay, and the spectral density is shown here, and this noise is put through a filter like this. So this is basically a first order filter, and you put the noise through this filter, and then you measure the power of your noise. Okay. Now think of another system where what you're doing is you're taking the same noise, but the filter is not a first order filter, but it's a brick wall filter, right? It's an ideal filter which has got a very straight characteristic. You normally you don't have such filters, but let's say you have, you're able to make that filter in some way. So you put this noise through this filter and you measure the noise power. Okay, and now what you say is, okay, this is my first order filter, and I know if I put this noise through this filter, how much noise is going to get through. What is the power of the noise at the output, right? Now, can I adjust my cutoff frequency of this brick wall filter? Can I adjust this fx in such a way that the power of the signal at the output of this filter is the same as the power of the signal at the output of this filter? Does that make sense? Let me repeat it. So what I'm saying is, can we adjust fx such that when this noise is put through this filter or this noise is put through this filter, you get the same noise? So you're adjusting fx so that you get the same noise power in both these filters. Okay, if you can do that, if you can get that value, then fx becomes the noise bandwidth of this filter. Okay, so in other words, so I've just written that out. The noise bandwidth of a given filter is equal to the frequency span of a brick wall filter. So this is the brick wall filter. It's equal to the frequency span of the brick wall filter that has the same RMS output noise as the given filter has when white noise is applied to both filters. So we apply white noise to both the filters and we say, okay, what should fx be so that the output noise power in both the filters is the same? Now, and then you calculate it, right? So if you get the value of fx, now why is that important, or where is it necessary? So if you know this fx, and this fx is called the noise bandwidth of this filter. So if you know the noise bandwidth of the filter, then basically instead of calculating how much noise comes out of this filter at the output, we can just look at this filter and say, well, this is the equivalent filter in terms of noise power, and I can just calculate the noise power from here, right? So it makes the calculation of noise power much more easier in this case. So for a first order filter, if the cutoff of the filter is f naught, the noise bandwidth of that filter is going to be pi over 2 times f naught. So the noise bandwidth is pi over 2 times the minus 3 dB bandwidth, which is the cutoff frequency of the filter.